Today we're taking a look at horizontal translations of sine and cosine functions. So you might remember from Chapter 1 that we talked about translations of functions, and that if we wanted to shift our graph to the left or to the right, we would add or subtract a value to x. Now if we added a value here, x plus c, then we were shifting our graph to the left. It's a little counterintuitive. And if we were subtracting our value, we were shifting to the right. So let's take a look at a specific example. We're going to graph y equals 2 sine of x minus pi over 2. Now we start this off the same way that we did the other graphs. We want our amplitude. We know that that is going to be equal to 2. Our frequency is 1, so the period is 2 pi over 1, which is 2 pi. We don't have a vertical shift, but we have a horizontal shift. Notice here, we've got x minus pi over 2, so this is going to shift pi over 2 units to the right. So the question is, as we draw our first cycle, how do we know where to begin and how do we know where to end? And the way that we do this is we set up an inequality. We know that before, when we would draw a cycle, that we were looking between 0 and 2 pi. But now we've got this funny shift happening, and if we solve this inequality, I'm going to add pi over 2, and we're going to get pi over 2, x in the middle, and 2 pi plus pi over 2 is 5 pi over 2. So instead of drawing a cycle between 0 and 2 pi, our cycle is going to be between pi over 2 and 5 pi over 2. So we'll set up our axes. And let's label going by pi over 2's. Here's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and then 5 pi over 2. So our sine curve has to begin at pi over 2 and end at 5 pi over 2. Now I like to label the important parts, right? We're going to start here. Our graph is going to increase, decrease. We're going to go through the x-axis right here, decrease, and then come back up again. So I'm going to draw those points in. We've got to go through here. We'll have a maximum here and a minimum there. And there is our sine curve. We'll label the y-axis. This is going to be 2 and negative 2. Label the function. And there you have it, a horizontal translation of a sine curve. Notice that here we're subtracting pi over 2 and our graph has shifted pi over 2 units. All right, we'll do one more. I'm going to change the equation just slightly. We're going to look at 2 sine of 2x minus pi over 2. So same thing you were doing before. The amplitude is 2, the frequency is 2, and the period is pi. We don't have a vertical shift, but we will have a horizontal one because we're subtracting some amount from the x. So we set up our inequality. It's always going to be between 0 and 2 pi. If you do that, that's going to give you the starting point and an ending point for one cycle. We're going to solve this, add pi over 2. And we get something similar to what we got on the last slide, except we still have this 2 over here. So we're going to divide everything by 2. And we end up with pi over 4 and 5 pi over 4. So notice if the frequency is not 1, that changes the amount that we're shifting to the left or to the right. So you can't go strictly by this number. You want to set up this inequality each time. So here we go. Axes. And let's go by pi over 4s. So here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. So our sine graph is going to start at pi over 4, end at 5 pi over 4. So start here, end here. We know it's got to go through the middle. It'll have a maximum and a minimum. We connect, and there you go. There's one cycle of sine shifted horizontally. Let's label our amplitude. This is 2, and down here we've got -2. And there it is. Okay, in summary, if you're graphing sine and cosine functions that have a horizontal translation, you start off as usual, you find your amplitude, frequency, and the period, but then you create that inequality to figure out what your start point and what your end point is going to be. And that inequality, let's say this is what your equation looks like. Your inequality looks like this. You take whatever is in the parentheses, put it in between 0 and 2 pi, and solve, and that's going to tell you where you start and where you end. You then graph your function using that starting point and end point, and then you label.